Hello and welcome back. In this particular video, we're going to be talking about our second method to go and create a function with our inverse, okay? So what I mean by that is if we have a function that does not pass the horizontal line test, how do we go and ensure then that our inverse function will also be a function and pass the vertical line test, okay? So this is an alternative method, and this is known as restricting the domain, okay? We need to really make sure that we're across restricting the domains of original functions so that we can restrict them. If we can't find the domain, we can't restrict it, okay? So first things first, unpacking this particular example. All right, if you remember from our last lesson, our last video, we talked about y equals x squared, and hence we also went and found the inverse, okay? Noting that that's actually x equals y squared, but I've rearranged to get y by itself. It's made up of two separate functions, i.e. this top function, okay, and this bottom function, coming from the plus and the minus, respectively. Now, if I include this bottom function here in green, okay, you'll notice it doesn't pass the vertical line test anymore. So we're going to restrict the domain so that we ensure that our inverse function will always pass that vertical line test. To do that, we need to understand about something called monotonically increasing or decreasing functions. Okay, here's our method. We're going to restrict our functions so that they are only ever monotonically increasing or decreasing. What does that mean? It means our function, okay, if it is monotonically increasing, is always going up. Okay, if it is monotonically decreasing, it is always going down. Okay, think if you're on this particular function, you are always walking uphill. If you're on this particular function, you are always walking downhill. Okay, mono meaning singular. Okay, to unpack the vocabulary there. All right, so one tonic, okay, being added on to the end of that, meaning that we're going to monotonically, so we're going to singularly and only increase. Okay, here's an example that is neither monotonically increasing or decreasing. You'll notice that I walk down the hill on this particular side and then I walk up the hill on that particular side. Okay, so let's go and look at a function, okay, something that you've seen before, and we're going to break it into the sections where it is monotonically increasing or decreasing. So you'll notice it's decreasing here, but it's increasing here. Let's have a look at this particular function. Okay, right, in terms of what's going on. All right, so there's a little bit going on. I want to really unpack everything that's going on here. I want you to first look at this particular sentence, okay? And from there, then I'm going to start explaining. I'm going to remove some information from the screen and then we're going to get back into it. Okay, so you'll notice my particular function is this parabola, x squared minus 4x. Okay, you'll notice in terms of graphing, it's going to have x-intercepts of 0 and 4. If you're in this video, I'm assuming that you're able to go and graph this. And what I have done is I have gone and I have unpacked where it is monotonically decreasing. So we are going down the hill on this particular side, right? And in green, you can see it is where we are monotonically increasing. Okay, so for your particular benefit, what I have gone and done is I've also included the vertex, okay? The vertex you can get by finding the axis symmetry, which in this particular case is 2, and substituting it back into this equation up here, okay? So what we want to go and do now is we want to go and find the inverse function. So I want to look at this algebraically, and then we'll come back to this idea of being graphically. So the information that I removed before is what's going to help us out here. So let's unpack step by step what's happening. We want to, okay, if our original function is this, y equals x squared minus 4x, we are going to switch the x and the y inputs. Okay, from here, you'll notice this is a fairly similar example to what we had before, where we had a bit of a tricky example to find the inverse. And what we want to start doing is we want to try and complete the square. Okay, so I'm going to get the y variables on the left-hand side, just so we're not focusing on them too much. And I'm going to complete the square on the y. So completing the square, I'm going to end up with y inside of some brackets, all squared is equal to x. Okay, and now I'm going to have inside of this is going to be half of the coefficient of y, which is -2, and I'm going to add that to the other side squared. Okay, going a little bit further, y -2 all squared. We're going to tidy that up. I'm going to end up with x plus 4. Going now and rearranging to get y by itself, I'm going to move the 2 to the other side, the square to the other side, okay, which will become a square root. So I've got y -2 is equal to plus or minus the square root of x plus 4. Don't forget that plus or minus, okay. Then I'm going to move the -2 to the other side, okay, and do its inverse operation, giving me my inverse function being y is equal to 2 plus or minus the square root of x plus 4. Okay, again, really unpacking this here, it's not a singular function, okay? And we know that because when I come back to this particular example, okay, we can see that it doesn't pass the horizontal line test, okay? Right, but what we can do instead, okay, is we can restrict it to where it's monotonically increasing, or restrict the function to where it's monotonically decreasing. Now let's just have a look at what that means algebraically. If we only look at where it is monotonically increasing, that is everything to the right of 2, i.e. greater than or equal to 2. Okay? This means this side of the particular parabola that we're talking about. So when I go over here to this particular inverse that I have created, all right, because I'm going to be greater than 2, I'm going to take the positive aspect of that particular inverse function. Okay, that would mean if I'm only looking at where my original function is monotonically increasing, my inverse would be that singular function there, and my domain would be such that it is wherever x is greater than or equal to 2. So I'm causing a restriction on the domain to ensure that it's monotonically increasing. Similarly, if I take the negative version of this, okay, my function now is monotonically decreasing, okay, and that happens on the left-hand side of 2. So my inverse is a function, okay, wherever x is less than or equal to 2. So I'm restricting the domain, okay, to wherever it is monotonically increasing or decreasing. Now, that might not necessarily make a lot of sense until we go and draw it, okay? So let's go in and have a little bit of a go so that we can see what's going to happen, okay? All right, so here we go. We're going to have a little bit of a look at the two different cases. Case 1 being where x is greater than or equal to 2, okay? And then case 2 we'll do wherever x is less than or equal to 2. All right, so I'll get you to pause here. Imagine that you are going to draw the case where you have restricted your original function to be monotonically increasing. Okay, and what you're going to do is you're going to draw the inverse function of only that arm of the parabola. I know that it can keep going, but I've just drawn it to that particular point to help you guys out. Okay, you're going to draw the inverse of only that particular point. I'll give you guys a little bit of a moment to have a go, and then I'll come back. Okay? Right, so unpicking everything, basically, I'm going to help you go and sketch the inverse of this particular function. Okay, so from our fact that we restricted to be monotonically increasing only, it is inverse f of x is equal to 2 plus or minus square root of x plus 4. Okay, alrighty, so some things that are going to help us out. When we go and we sketch inverses, we know that our x's and our y's switch, which means that our vertex coordinates are going to switch to, instead of being 2 and -4, to becoming -4 and 2. So we're going to actually switch the coordinates of the vertex, noting that this particular thing will come up here, okay, meaning that my new inverse function is going to come down here. So we want to pick that pick its starting point. And this is why it's really, really hard to only do things algebraically. We need to kind of put all of the ideas together. Okay. Alrighty. So if it's going to be at -4 and 2, All right, I'm going to go and do a similar point sort of coming off, okay, off the y-axis, and I'm going to put my point there, and that's going to be at -4 and 2. Okay, alrighty. So now I'm going to sketch my inverse function, all right? Noting that I can rotate it 45 degrees, and I'm going to make it mirror the original function that's highlighted there in green for you, okay? By going on the other side so that it looks like that. Okay. All right. So in blue there, that is my inverse function, and it will continue on, right? Noting that it is a parabola, but I've just stopped it there at the point where it hits the line y equals x. Okay. So let's unpack what's happened there just so we can understand. I've reflected this purple component that's highlighted in green across y equals x, and that's given me the blue component. To help me out, algebraically, I've taken the vertex of that point, and because I'm finding the inverse, we switch x and y, okay? Which gives me that starting point there. So my x is 2 and my y is -4, which means my x is -4 and my y is 2. Okay, that gives us a really, 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 really solid foundation to go and work with. Okay, alrighty. Now, let's draw the other case where we restricted our function so that it was monotonically decreasing, i.e. wherever x is less than 2. Okay, we ended up with y equals 2 minus the square root of x plus 4. Something that I want to point out that is often a misconception for students. We said here that x is greater than or equal to 2, but I've drawn my inverse function for values that are less than x equals 2, right? i.e. on this side of it. That's okay because all we're doing is we're restricting the values of x that can go into this function, okay? There are transformations that have happened that have dragged it sideways, okay? Alrighty, so using that, this restriction comes from the original. We can still go and sketch, okay, based off of transformations in the inverse, and we will be okay. Alrighty, so now let's go and sketch this, all right? First things first, it's completely and totally up to you how you might attempt it. I might sketch out a little bit of an idea so you can see what's going to happen. I won't tilt my screen, okay, so you can see the easy way, but I will go and graph off of it. So the first thing that I'm going to highlight to you is the fact that on the line y equals x, this arm up here goes up and to the left, okay? Which means that my new arm, okay, will start at the origin and will go down and to the right as most accurately as we can. I might reattempt to draw that. Okay, we'll go down and to the right. Now looking here, this other aspect, it also, okay, travels from the line y equals x and goes off and to the right. Okay, so this line here will go off and to the left from the origin. However, the coordinate that this goes off to is at 2 and -4, which means that the new coordinate that my inverse function will go to will be, because algebra causes us to switch it, -4 and 2. Please note my graphs are not to scale, but they do help you give a bit of an idea in terms of what's happening. So this will go off and to the right, okay, and my inverse will go off and to the left at this particular point. Okay, so unpacking that, all we're now drawing is where we have restricted our original function to be monotonically decreasing. Now have a little bit of a look at now our inverses now. You'll notice now this blue graph clearly passes the vertical line test. It's now a function. Same thing here where we've restricted our graph to be monotonically decreasing, okay? The wonderful thing is where I look at my inverse function, it is now also a function, okay? It now passes the vertical line test, okay? In the next video, we're going to talk about how we do this a little bit algebraically from the original function so that we can be really, really consistent in terms of how we approach it, okay? I'll see you in the next video.